Hey guys, hope you're having a great day. So what we're going to do today is we're going to finish up Unit 7. We're going to finish up polynomial operations, and then we'll do standard assessments on this starting next week. So the rest of the week after your assignments due Wednesday by 11:59, you'll have Thursday, a couple days next week to work on the review, and then probably Wednesday and Thursday next week we'll have assessment standards review. Okay? So the last thing we're going to talk about all this week, we've been talking about applications. So on Monday, we did perimeter. On Tuesday, we just did area, basic area, base times height. So today what we're going to do is find the area of a shaded region, okay? So how do you find the area of a shaded region? Well, the easiest kind of thing to do it, you find the area of the big figure, subtract the area of the small figure. So you find the area of the big, find the area of the small, and then subtract the two, okay? So let's use this rectangle right here. They tell us that the big rectangle is 4x and 3x plus 2. So I'm going to take 4x to the first, again, I'm going to put my 1 there, times 3x plus 2. Okay? So I'm going to do that first, find the area of the big first. So I distribute 4 times 3 is 12. Since I'm multiplying, I'm adding my exponent. So x1 and x1 gives me x2. Then I do 4 times 2 is 8. x1, no x. I just bring down my x1, okay? So I have my area of the big minus, I then have to find the area of my smaller figure. Well, my smaller figure is this little rectangle right here, and they're gonna give you the measurements for it. And they tell me that that rectangle is 2x times x plus 1. So I put 2x to the first, and then 1x, and x to the first plus 1. I like to put all my 1s there so I know when I'm multiplying them, okay? So I do 2x times 1x. So 2 times 1 is 2. x1 is x2, okay? And then I distribute it to the 1. So 2x times 1 is 2x. So that's how I get to this step right here. 12x squared plus 8x is the area of the big, minus 2x squared plus 2x is the area of the small. Now I'm going to subtract them back to what we did a couple of weeks ago when we're adding and subtracting polynomials. I first need to distribute my subtraction sign to the polynomial on the right. So I do a negative 1, there's an imaginary 1 there. Negative 1 times 2 is negative 2x squared. And negative 1 times positive 2 is negative 2x. Again, these are to the first. And once I distribute my negative sign, the parentheses drop, and all I do is combine like terms. So again, I did a squiggly line under all of my x squares, and I did like a tilde under my x's, and I combine the ones that look alike. But when I combine, I add the coefficients, the numbers in front of the variable, but the exponents on the variable stay the same. With multiplying, we add exponents, with adding, we don't. That's the part we might get confused, so make sure you take your time there. So I do 12x squared and a negative 2x squared. So if I have $12 and I spend $2, I have 10x squared left, okay? Subtraction is just kind of like spending money. And then I have an 8x and I have a negative 2x. So same thing. I have $8, I spend $2, I have $6 left. I cannot combine these two. I can't go any further. If I could, I would, because they both have x, but the exponents are different, so I can't combine them any further. So my answer here would be 10x squared plus 6x, okay? There's one problem like this on the worksheet. It's the very last one, okay? What I suggest you do is just find the area of the big, do that separately. Find the area of the small, do that separately, and then do area of the big minus area of the small, and take your time with it. There's a lot of room for little errors here, but I know you guys can do it. If you have any questions, make sure you log on to Zoom. Have a great day. Talk to you guys later.